And number 25, they want you to describe a sequence of transformations. Now in this case, because they want you to map A, B, C onto D, E, F, we know that A is going to align, or it's going to match up with D, B is going to match up with E, and C is going to match up with F. If you notice, if I slide this triangle 1, 2, 3, 4, 5, 6, if I slide this 6 units, I'm going to call this a translation of, 6 units. And then what it looks like it does is it looks like, since all these are the same distance away from each other, well, I should say A is the same distance of D and B is the same distance as E, this is going to be, then it's going to be a reflection over the x-axis. Number 26, we know that point A has the coordinates 4, 2. Point B has the coordinates 22, 2. We know that the proportion, or the ratio of AP to PB is 4 to 5. Okay? Well, in total, this is 4 units. This is 5 units. This is just a scalar. The total distance is 9. In terms of the ratio, the distance is 9 units. So in terms of the ratio, we know that from A to P is 4 units. We're basically going to be looking for a ratio of A to P to the whole segment. So what I'm going to be doing is this. Watch this. 4 units, and then the entire segment in terms of the ratio is 9. Well, in this case, we know that the segment is 18. In terms of the coordinates, we know that it's 18. So using a proportion, we're going to cross multiply. I'm going to get 9x, and that's going to be 72. What I just found is that distance, AP, is 8. So that makes this 12 and 2. I know it's 2 because those values did not change. The answer is 12, 2. They want you to explain why AB is parallel to CD. Well, if this top segment, 375, is in ratio to the entire segment, so we'll say 8.75, if it is equal to the proportion of that side, 4.5 and 10.5, if this is in proportion, then these two lines are parallel. If this segment to the whole segment is in proportion with this top segment to this portion, then these two lines are parallel. So in order to test for proportionality, what I do is cross multiply. So I do 8.75 times 4.5, and I'm going to do 3.75 times 10.5. Using my calculator, you will see that this is 39.375, 39.375. So since these cross products equal, these are in proportion, and if these are in proportion, these lines are parallel. Your explanation would look something like this. Now, since their cross products are equal, they are in proportion. What I mean by they are these segments. In this case, if I drew a triangle, this might not drawn to scale. It might not be drawn to scale, and if it's not, I apologize. It was a rough sketch. In this right triangle, you have approximately a 73-degree angle, which it says right there. This is my 90-degree angle. Okay, so the sine of 73 is 9.5 over 10. They want you to find a value. Sine is the opposite over hypotenuse. So what they want you to do is find a value for this missing angle. This is R. The reason why we know that is because in this case, cosine of R is going to be the adjacent which is 9.5, and the hypotenuse is 10. Sine of 73 gives you 9.5 over 10, and then the cosine of this angle is going to also give you 9.5 and 10. So in a relationship here, the sine of angle A is always going to be equal to the cosine of that angle. Always. So if I gave you some triangle where I said this is angle C, this is A, and this is B, sine of A will always equal cosine B. Well, in order to find this angle, there are 180 degrees in a triangle. You already know 90 because you're working in a 90-degree triangle. Okay? Well, if you have 73, now you're going to subtract 73 and you should have 17. So the value of R is 17 degrees.